All right, so we looked at the stretch and compression that was done when multiplying by a value A, whether it opened up or down, if it was stretch or compress. Now we're going to talk about transformations. And so how can you obtain the graph of g of x equals a x minus h squared plus k from the graph of f of x equals x squared? And so this form here is what we call vertex form. And you'll see why here shortly, why we call it vertex form. Now, every quadratic function can be represented by an equation of the form g of x equals a x minus h squared plus k. The values of the parameters a, h, and k determine how the graph of the function compares to the graph of the parent function y equals x squared. So a vertical shift of a parabola is a shift of the parabola up or down with no change in the shape of the parabola. So the graph of the function y equals x squared plus k translates our graph up, and the graph of the function f of x equals x squared minus k translates the function down. So let's work through one here and see how this comes out. So let's pick some points. Let's go -2, -1, 0, 1, and 2. So -2 squared is +4. And then we're going to do that -2 squared, which is +4, but this time we're going to add 2, which makes it 6. -1 squared is 1, but now +2 is 3. 0 squared is 0. +2 is 2. And then we get our reflection. So go ahead and plot our initial. So my x squared, okay, will be in blue. So there's our parent function. A little less wave in our graph there. Let's see. And then let's do our second one. We'll do this one in red. So -2 and 6. -1 and 3. 0, 2. And as you can see, essentially the same graph. It has now just become shifted up too. So that changes a few things. Like first, our vertex now is at 0, +2, because now it's that location there. Our axis of symmetry is still x equals 0 because it goes through the x coordinate of our vertex. Now our graph is opening up, so we have a minimum at y equals 2 this time because that is our lowest value right here. It's also our y coordinate of our vertex. Our domain, hey, nothing's changed on that. We're still -infinity to +infinity. Our range now, as we look at this, we start down here at our -infinity, nothing, 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 until we hit +2. Don't forget your close bracket, and then our graph continues to increase all the way up to +infinity. All right, so let's do another one now. So let's go try same values, and we'll get 4, 1, 0, 1, and 4. This time we're going to subtract 5. So we get -1, -4, -5, -4, and -1. So we plot those. I'm just going to plot the red one this time, our x squared minus 5. So -2, -1, -1, -4, 0, -5, and then reflect it across the way. And you can now see that our graph, same deal, is just shifted down 5. So then our vertex of this is going to be at 0, -5. Our axis symmetry is at x equals 0. We still have a minimum because our graph is opening up. So we have a minimum at y equals -5. Domain doesn't change here on quadratics. And then our range, all right, let me write this as inequality just so we still see how that can be written. And our range, I'll write as both again. So we start at -5 and we go all the way to positive infinity, or we can state that y is greater than or equal to -5. All right, so moving on to the next type of transformation. So a horizontal shift of a parabola is a shift of the parabola left or right with no change in the shape of the parabola. So now this is where this one gets a little tricky. So the graph of the function f of x equals x minus h squared now actually translates our graph to the right. And the graph of the function f of x equals x plus h squared translates our function to the left. Okay, so let's take a look at a couple. So again, pick our points. We'll go -2, -1, 0, 1, and 2. And with this, we'll start to see why there are some issues, why graphing with a table can create some problems. So as we go substitute in, we get -2 minus 1 is a -3. -3 squared is 9. And then we get -1 minus 1 is a -2. -2 squared is 4. Then we substitute 0 in. 0 minus 1 is a -1. -1 squared is 1. And now from here, we would normally just reflect the values, but to be safe, we'll check. And I want a 1 there, not a 0. So let's go 1 minus 1 is 0. 0 squared is 0. So it didn't reflect. Normally that 4 would be there as well. So let's check when we substitute 2 in now. So when I go 2 minus 1 is 1. 1 squared is 1. So now we're starting to reflect. So let's graph it and see what this looks like. So -2 is 9. -1 is 4. Let's go 0 is 1. And then 1 is 0. And now 2 is 1. So you can see that same shape is taking place. But now it is now just shifted over. So, and as we see it is x minus 1, as we talked about, when it's x minus h, that is a shift to the right. So there's our shift to the right. We went over 1 to the right. Now our vertex, our x-coordinate actually changes for once, so that's fun. So now we're at 1, 0, mixing it up a little bit. Our axis symmetry actually nicely changes with it, and our axis symmetry is now x equals 1. No more just boring zeros in there. We're still opening up, so we are a minimum at y equals 0, because that is the y coordinate of our vertex. Domain hasn't changed. And our range goes from 0, which is our y coordinate of our vertex, and opens up, so it is to positive infinity. All right, so let's go with our normal set of values for x. So -2 plus 2 is 0. 0 squared is 0. Then we go -1. -1 plus 2 is 1. 1 squared is 1. Then we go 0 plus 2 is 2. Squared is 4. And then 1 plus 2 is 3. 3 squared is 9. And 2 plus 2 is 4. 4 squared is 16. So as you can see here, nothing actually got reflected. So let's plot our points and see what we look like. So we get -2, 0, -1, 1, 0, 4, 1, 9, and then 2 and 16, so somewhere up here. So we have, looks like maybe one half of a parabola, so that's what's hard to tell, is does it go back up? Does it continue to go down and go back up a little bit? So now you can see one of the issues of graphing with the table is we got to be specific about some points that we pick. So I'm going to pick another point. I'm going to put up here, let's go -3. So let's go -3 in here. -3 plus 2 is a -1. -1 squared is 1. So we at least know we start to go back up here. And there's our parabola there. Hey, again, we see a shift from 0, 0 to 2. And it's left because that is x plus 2. We talked about when it's plus h squared, that is a left shift. And let's fill in. Our vertex now is at -2, 0. Our axis of symmetry, x equals -2. We have a minimum at y equals 0. Domain is -infinity to positive infinity. In the range, we'll do an inequality method as y is greater than or equal to 0. All right, so now let's do one that has everything involved in it. So the vertex form is this form here. Gives you information because the HK is where our vertex is located at. The axis symmetry is at x equals the x coordinate of vertex, which is h. Our concavity is based on a. If a is greater than 0, it opens up. If a is negative or less than 0, it opens down. Just like when we did absolute values, still is the same. And then our stretch factor also comes from a. If a is greater than 1, it is a stretch. If a is actually between 0 and 1, it's a compress. All right, so our steps to graph are nice and simple. You want to identify your vertex. It's HK. Notice that this is negative H, so we just want that value. So it is the opposite sign, just like it was with absolute values. Our concavity, we want to identify that. Then our stretch factor, and then we want to sketch the graph. All right, so as we look at number 5 here, our HK, so we have x plus 1, but remember it has to be x minus some value. So that's why we get that negative 1. So it's negative 1, negative 2. Our concavity, we're going to be concave down because our A is negative. And then we're going to be, our stretch is actual stretch because we're just looking at the actual numeric value, and 3 is greater than 1. So I should actually say that up here. Our stretch factor comes from our A, and so it's the absolute value of A, because we actually don't care about whether it's positive or negative. We just care about what the actual numeric value is. All right, so to plot this, pick a couple points. So we have our XY table, and I want to pick negative 1. We already know that's negative 2, and then I want to pick 1 point on each side of it. So I'll pick negative 2 and 0. So as I substitute negative 2 in, we get negative 2 plus 1 is a negative 1. And I'll write all this out. So we get a negative 1 inside here. Negative 1 squared is 1. 1 times negative 3 is negative 3, minus 2 is a negative 5. So I get negative 5 here. And then we do the same thing with 0. And once you calculate that, 0 gives us negative 5 as well. So that gets reflected because we chose this point to be our vertex. So negative 1, negative 2. And then negative 2, negative 5. Let me zoom in here. And 0, 5. And there's our graph. Now, unfortunately, this doesn't give me the best drawing capabilities for these quick curves. So I get a little shake. Remember, these are curved parabolas. They should look something more like that, not absolute values where it's straight lines. All right, let's do this next one. Our HK is at 1, negative 7. Concavity, our A is positive, so it's up. So there's our A, it's a plus 2. And then again, our stretch, we are stretch on this one because our A is greater than 1. So again, pick some points. And pick points on each side, so I'm going to go with 0 and 2. And then once we work those out, we get negative 5 and negative 5. So let's go 1, 7. Issue on our transfer error. I have negative 7 over here, but I wrote positive 7 there, so we get 1, -7. And I get 0, -5, 2, -5, and we got our parabola there. All right, your turn to work on a problem here. And we'll discuss this one, come back into class. And then you have a quizzes to do. Do not forget to complete that so you get full credit on your notes on this one. And then a little reflection question. I want you to answer, how do you tell from the equation whether the vertex is a maximum or minimum value? Okay, we'll discuss that in class, along with our essential question here. And then your assignment, page 232, numbers 1 through 9 odd, and then 10 through 21.